So today what you're going to be learning about is parallel lines and transversals. So this is something that you have probably seen before when you were in middle school. So here in our picture you can see that we have two parallel lines. We'll name them L and M, and I know that L is parallel to M. Now those are written in cursive because that's the way that mathematicians do it when we're naming a line. Now, because they're lines, what should they have on each end? They should have arrows. Our transversal is also a line, so I'm going to put arrows on it as well. A transversal is a line that cuts through two or more lines. Now we're going to be talking about how all of these angles relate to each other. So you can see that the first two we're going to talk about are called corresponding angles and vertical angles. Vertical angles you actually already know about. You learned about those in your last video. So for an example, a set of vertical angles on this one is angle 2 and angle 4. You can look at angle 2 and angle 4 and you can see that they are across from each other. Now, we have multiple other examples of vertical lines. Vertical angles. You have angle 1 and angle 3, angle 6 and angle 8, and angle 5 and angle 7. What might be a linear pair? We have lots of linear pairs as well. One example of a linear pair would be 1 and 2, or angle 1 and 4, or angles 8 and 7. So let's talk about each of those. With vertical angles, we know that the angles are always congruent, meaning they're the same. This is the symbol for congruent, a squiggle line with an equal sign underneath it. That's congruent. For linear pairs, we know that they are supplementary. So supplementary. These pieces of information are what you're going to use to solve for missing angles when you're given a problem of parallel lines. So the only other one that is new is our corresponding angles. Corresponding angles are angles that are on different parallel lines but are in the same place. For example, on this one, we have two parallel lines. Angle 2 and angle 6 are corresponding angles. Angle 2 and angle 6. Now look at where they're placed. On line L, they're in the top right-hand side. On line M, they're on the top right-hand side. If you look at the shape of them, you can tell that they are congruent. When a line cuts through another line, it creates angles. And if you're cutting through two parallel lines, the exact same angles are always created. Angle 1 is congruent to angle 5 because they're corresponding angles. Angle 4 and angle 8 are corresponding angles, and angle 3 and angle 7 are corresponding angles. Now might be a time to pause to get this down before I move to the next page. Now we're going to talk about how the rest of them relate. Alternate interior angles. Now, I'm going to circle these. And alternate interior angles are on the inside of the parallel lines. That's what interior means. Alternate means that they are on opposite sides of the transversal. So alternate interior angles would be angle 4 and angle 6, and angle 3 and angle 5. Alternate interior angles are always congruent. Alternate exterior angles are on the outside of the parallel lines. So an example of an alternate exterior angle would be angles 2 and angles 8, or angle 2 and angle 8. They're on opposite sides of the parallel lines and they are on opposite sides of the transversal. So angle 2 and angle 8, and then angle 1 and angle 7. Those are also always congruent. Same side interior would be angle 4 and angle 5, and then same side exterior would be angle 1 and angle 8. Same side interior angles 4 and 5 are supplementary. and same side exterior angles are supplementary.